So let's consider solving this example. So example 1, for the marginal revenue function MR, which is 35 plus 7x minus 3x squared, find the revenue function and demand function. That is, a firm has the marginal revenue function given by MR, which is equal to A over X plus B all squared minus C. That means, sorry for that, I've mixed two questions here. This is not part of the question. So let's see something here. So let's solve this question here. So find the revenue function and demand function here. A firm has the marginal revenue function given by MR equal to A over X plus B all squared minus C. And where X is the output and A and B, C are constants, we should show that the demand function is given by X equal to A over B into bracket P plus C minus B, as you can see over here. So let's solve this example. So as we said earlier, they said we should show that our demand function is this. And before you can get your demand function, you need to calculate for your revenue function, and after that you divide by X. So in doing this, this is our marginal revenue, which has been given to us, which is equal to A over X plus B all square minus C. So to make this solution simple to us, for us to integrate, we can simplify it as A into bracket X plus B to the power negative 2 minus C. So in doing this, we need to find the integral of both sides, which is integral of the marginal revenue, which is equal to integral of A X plus B plus negative 2 minus C is a constant, right? And we are integrating with respect to dx. So C, that's integral of C, maybe dx as well. Here is dx as well. So in doing this, when we integrate our marginal revenue, we are going to get our revenue function. And therefore, as usual, here is a constant A. We bring it out, so A out here. So in this one, we can use a shortcut here. We have X plus B power negative 2. So what we need to do is that bring this constant down, which is negative 2, and then you add plus 1 here, and you take this whole function X plus B, and then we add negative 2 plus 1. And remember that we need to differentiate whatever is inside here, and then we multiply by here, by the whole function. So when we differentiate this X, we get 1. But when we differentiate B, we get 0. So when we differentiate X, which is one term here, we get 1. So multiply by what? 1. So at the end of the day, we are going to get to be X plus B all to the power negative 1 over negative 1. So that's what I want you to know, how you can do that. So let's move ahead and then solve the question. So as I said earlier on, you are going to get A multiplied by X plus B power negative 1 all over negative 1. And then minus, when we integrate C, we are going to get Cx. And don't forget that we need to introduce the constant K. This arbitrary constant of integration. So after getting this, we can say that our revenue function is equal to negative A over X plus B, because when we bring this one to the power negative 1 down here, we are going to get X plus B exponent positive 1, and then minus Cx plus what? K. So in doing this, we can say that when you have not produced any items to sell, you don't have any revenue to generate at the end of the year. Therefore, if X is equal to 0, my revenue is also equal to 0, and therefore my revenue is equal to 0. I can say I'll have something like 0 equal to negative a over 0 plus b plus 0 plus k, and therefore I'm going to get 0 equal to negative a over b plus k, and therefore my k equal to a over b. So now, having the k equal to a over b, you need to substitute it back into the function. So substituting it back into the function, we are going to get our revenue function to be equal to negative a over x plus b minus c of x plus a over b, which is our k. Right. So in doing this, what did they tell us that we should find? What did they tell us that we should find? They said we should find the demand function. But can we further simplify this? We don't know. If you can further simplify it, we can make this one a common denominator. Let's say we can make, since this one contains a and b and this one has a and b, we can make them a common denominator and then move on from there. So we can see that our r equal to a over b minus, right, a over x plus b, you get me, minus cx. We want these ones to have a common denominator, so we can say our times b multiplied by x plus b, and therefore in doing this we are going to get what, a multiplied by x plus b, right, minus a then multiply by b. You get it from here. So don't forget that minus cx here, and then at the end of the day you are going to get, when you simplify the top here, we have ax here, we have ab here, and then ab here. So ab here will cancel this ab, that will appear here. So now we are going to get ax over what, b into bracket x plus b, right, x plus b minus cx. And therefore we said that we should represent our demand function d at the revenue function over x, and therefore our revenue function, our demand function, is equal to ax over b x plus b minus cx all over x, and therefore our demand function at the end of the day, we are going to get something like, let's say ax over b x plus b divided by, so at the end we are going to get multiplied by x because we return it. And at the end of the day we are also going to get c out here over x. So x will also cancel x, right? So getting this, you are going to get d equal to this one. But if you have d equal to this value, remember that this x also cancel this x as well. You're going to get d equal to a over b into bracket x plus b and then minus c. So let's get back into our question and see what they are asking for. So in the question they are saying that we should show that our x equal to a over b into bracket p plus c minus b. That means that our demand function is being represented as p, so we will change it as that as well. So now that means that they represented the demand function as what? P. So let's do it as P as well. So making X the subject, we're going to get PB into bracket X plus B equal to PB equal to into bracket X plus B, right? Minus, let's say, equal to A minus C to bracket B multiplied by X plus B as well. So in this case, we need to group like terms, so we can say that we have or expand it BPX plus BP squared, which is equal to A minus CBX plus, remember that the minus affects everything, plus CB squared. And therefore, having this, we can group like terms as well. So when we send this one here, we're going to get BPX. Now this one will affect this one as well. So we are going to get plus here CBX, which is equal to, remember here it's going to be negative. So we're going to get A minus PB squared. A minus PB squared. And then here the minus also affected minus CB squared. And here when you bring the X out, we are going to get PB plus CB, which is equal to A minus PB squared minus CB squared. So when we divide it, PB plus CB, so B is a common term inside, right? So at the end of the day, PB plus CB. So based on this, we can say that we can have our A over B out P plus C, and then minus, when we do minus here, and then it means that here will become positive, right? So let's bring one B out. So if we bring one B out, let's say B squared out, P minus C all over B out, all over B out, getting P plus C. So we get this one of the B out, and at the end of the day, you are going to get something like P plus C here, and then here is also P minus C up there, P minus C up there. Let's see how things go. And P minus C, and then remember that this negative one here remember that I forgot this one too. Remember that I factorize this negative out. So when I factorize negative, I'm going to get negative into brackets PB squared plus CB squared, right? So in this case, since here is P, this one can cancel this one out, and we have only one B here. So at the end of the day, we are going to get something like A into bracket B over P plus C minus what? B. So the question was asking us, what should it be equal to? Which is X equal to, we got A over B P plus C minus b, which is the same thing over here, which is our x. So that is how you go about this question.